ladies and gentlemen, good morning, and here we go into the last frontier. So we go on to space this morning with our Fin sessions, and delighted to start us off with Peter Humphries, who's the president of ASMS, and he's going to be talking to us about really the practicalities of building the right kit to get us to do the thing we're trying to do. Ladies and gentlemen, Peter Humphries.
Good morning, ladies and gentlemen, and Li Hao to people that are here from China. So I'd like to introduce the innovation of space exploration colonization technology. My colleague, Mr. Thomas Brandt, he's in the t-shirt, space t-shirt, and Mr. Gavin Spears. I'll go over the outline, I'll do the introduction, design, applications, and summary. Space exploration dates back to the 1960s when spacecrafts were launched. With the exception of a few pioneer missions such as the Galileo, the Hubble telescope, not much has happened until recent times, where many countries and organizations have started to rethink the exploratory missions to the Moon and Mars and consider building colonies to the benefit of the scientific community. Recent innovation in a form of disruptive technology came about with a private industry participation in space cargo delivery. The ASMS Space Utility Module is a disruptive and innovation set to revolutionize the space exploration with the development of a platform engineering architecture for building colonies. The ASMS Innovative Space Utility Module is a structure with a unique set of benefits for upgradability and reconfigurability with a slidable platform on rollers. We are the first module designed with a set of double doors for full interior access, incorporating the International Berthing Docking Mechanism standard. We are the first utility module providing colonization technology for in orbit, in situ, as well as on the planet such as the Moon or Mars. We have a US and European patent for the space manufacturing module system and method, and we filed a US provisional patent May this year for the double door system. Concept. The ASMS Space Utility Module will provide a habitation environment in support of manned missions for space exploration. This module is in the form of a cylindrical vessel. It is equipped to accommodate the crew. The specific benefit of this module is to empower the space community in support of long duration expedition utilizing a flexible, upgradable platform on rollers. The major goal of NASA and the European space community and private industry is to develop colonies on Earth, Moon, Phobos, Deimos, and Mars. The Space Utility Module will enable the space community to deploy a series of such modules in support of establishing colonies for various applications such as habitation, lodging, leisure, manufacturing, medical, and scientific research in a safe environment. That's a prerequisite. Design parameters as of 2018. I won't go over all these, but I'll just pick a few out. Case 1, 10 kilowatt with an astronaut. Case 2, without astronaut and a habitation module. Data volume, 20 JB approximately. We are at TR level 3 with a mock-up layout in progress. 15 years, depends on the application, whether it's in situ or on the lunar surfaces. We are in the process of developing a track robot, TRL-4, to work inside the habitation module or do recon for a geologist, per se. Design, the ASMS Space Utility Module with the double doors. As you can see here, we got the hatches. This is the IBDM, the hatch is starting to go up. Outer doors, one at a time, turn 180 degrees. Hatch doors on the inner one, starting to move up on the inner doors. Both outer doors are open. Inner doors start to open. Design. The sterile structure is made of Kevlar, carbon fiber, titanium inner shell. Design analysis on the pressure vessel. As a pressure vessel, the module could sustain 0.0 MPa of internal pressure and a 4.3 G load during launch. The module can also survive impact of space particle 2 centimeter size and impact velocity of approximately 17,448 miles an hour. Safety is key with a Kevlar layer. Structural analysis. Analysis of the structure of the Space Utility Module was completed and carried out with sound, proven engineering principles. Launch analysis was based on Delta IV rockets. As new iteration of space launch vehicles come out, we will change the spec to meet that requirement. Internal pressure set at 14.7 psi. Impact analysis based on ANSY's software. Here's a structural analysis of space utility with the wall structures. Thermal analysis simulations were carried out with MIL and pattern configuration coupled with air blowing on the internal equipment. With a laser welder cutting 3D printing machine at LEO, the following design spec choices were able to keep within these specs. At GEO, the buff process was a similar temp. Additionally, when the titanium shell thickness is increased at GEO, they still allowed the space utility module to operate at the same equipment temperature range. This goes to show our engineering processes were fundamentally correct, that we've done our homework. This is a chart of our, over time, our thermal analysis. We've done our thermal and radiation. Obviously you don't want to die in here. And that's the 3D printer putting out the heat, laser welder printer. Applications. Space hotel, construction, material science, fabrication, research, medical surgical unit, a biological science research facility, greenhouse and fresh food produce module, satellite capture and repair, deep space gateway module with Earth, Moon, lunar orbit, enhance the space app capabilities beyond existing International Space Station. deep space transport applications to go onto Mars or wherever man wants to go. This shows one of the layouts that be configured on the lunar surface. You can see the IBDM here, International Berthing Docking Mechanism, and we just got a couple of geologists going for a walkabout to find out whether maybe helium-3 to run equipment on. Here's a cut through, and you can see the double door mechanism. We're not going to disclose everything. We're keeping a lot of this close to our chest of the double door system. AMS Space Utility Module with a reconfigured as a botany greenhouse research lab. Again, everything's attached to the floor. So later iterations of technology, you just slide that floor in. Obviously, the pioneers want to be comfortable on the moon or on Mars applications. So this is an artist impression of our modules being on the lunar surface or Mars. Again, these platforms can be slid out and upgraded as new breathing apparatus comes along. In summary, the ASS Space Utility Module is an innovative, disruptive technology for the development of colonies. Utilization of a set of double doors on the Space Utility Module will allow full interior access. Novel in situ habitation module for a variety of applications such as space hotels, medical surgical units, scientific research modules. ASMS Space Utility Module is an enabling technology that can provide the scientific community with the capabilities to achieve objectives in deep space and beyond for their applications. We've done a lot of work. We have over 24 papers and presentations that we've done. Advanced Space Manufacturing Systems. We're based out of San Jose and out of Wells, Somerset, England. We're going to be presenting, co-authored on some papers at the International Space Station Conference next week in San Francisco. And we'll be presenting technical papers at the American Institute of Aeronautics and Astronautics in January 2019 in San Diego. ASMS is seeking collaboration, patent sale, and licensing opportunities. Come and meet us to experiencing an exciting virtual reality demonstration. I will take any questions that you may have now. Any questions? Yes, sir.
What was the weight of the whole system?
The weight, yeah, go ahead. The weight.
Weight of the whole system. What do you?
Okay. We cannot tell the customer what they're going to put on that platform. They know, as we now know, it's $10,000 per pound to put something in space. I'm just flicking back, if I've got a spot for it. Here it kind of shows you. We're not going to tell the customer what to put on that platform. Yeah. Yeah. So, there. Okay. I hope if any other questions, you can pull us aside later. Someone else got a question? Yes, sir.
Yes. How do you plan to deal with what's called the regolith on Mars? All the dust the astronauts came back covered in.
That's see this here? We're going to put that is to stop back contamination. So if a geologist wants to put a sample here, You could call this like the changing room. So you can get all your gear off, derobe, and then in you go into the habitation mod. You can put many of these modules together, and so if you want a clean room, you can have it. It's up to the customer. We're not going to tell you what to do. We're just giving you the shovel to go and do the job, the tool to do the job. Any other questions? Thank you very much. I'd like to say thank you for Faber to giving me the opportunity to present here today, and I look forward to meeting you at a later date. Thank you very much, ladies and gentlemen.